Good evening and welcome to Flat Earth Debate. I'm your host Nathan Oakley, and if you are new to this channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live, and if you would like to join the debate, there is a link in the info box below this video. With your watch page muted, simply click on that link to join the debate live. There are only a couple of rules in the Hangout. Number 1, please do not swear. Number 2, if you are ejected for swearing, please do not try to rejoin the show with a sock account. I'm going to transition to my photographs while I sort out a few technical hitches, as I just lost my internet connection. So this is technically a part B show, but I do think the link is now a new one. So if you could be so kind as to share the show on Facebook, Skype and Twitter, as it is now a new watch link. So I'm going to do exactly the same, so you'll have to bear with me. There will be some silence. Hopefully there are a few people still in the Hangout page when I reconnect to it. We shall see. Oh, there's quite a few guests. Excellent.
Yeah, like I said,
Go ahead.
Nathan's fixing his audio, I think.
But no, you're good, man. But
we are back on the air, gentlemen and lady. Sorry for the interruption.
Hey. Welcome back.
But yeah, that's it, man. You measure it using that instrument, and it always shows objects in the distance lower than they should be on a flat Earth, and as low as they should be on a round Earth. Depending, sometimes you get some weird refraction stuff. But
so basically what you're telling me is that just one picture that a guy took and put it on the internet, you just believe that, and that's all you need to know to stay a baller, and for the rest of your life, no matter what proof anybody comes up with, you're gonna be a baller no matter what. And there's not anything any flat earther could ever do that would prove to you that it's flat.
Okay, so yeah, David, you seem like a nice guy, right?
I'm on the flat earth team, put it that way. And I'm gonna step up to I'm gonna step up to the pump. Nobody else wants to step up to the pump and answer the questions. I'll step up to the pump and say, just going from Chicago to Chile will prove that it's flat.
Right, but here's the problem, though. You just said that you made the claim that I am happy with this one single picture and I'll never look at anything else. But that's very
How about the picture of Earth in space? Is that real?
Hang
on,
David.
Real? Answer that real quick. Is that real picture?
No.
It's not a picture. It is fake.
I showed you 3 different videos, and I said there are several more, and other people there are like thousands, right? And you can buy your own. So to say that I took this one picture and ran with it is really kind of dishonest.
That's one down, actually, like we were talking about earlier. We got to have the 100 guys and 100 proofs.
Right. And so what's wrong with this one proof?
That's a good one. Explain that. I don't have any problem with it, other than I don't know the scientific parameters of how this thing was done or how they're doing this, and I haven't sat down and researched it. So I'm not going to say that I understand everything about this piece of equipment, because I don't. It's just like I could take you and put you in my truck and say, here, take this thing to California, and you probably couldn't crank it up. But that's the whole point here. Everybody has to be taught. There's common sense about how to do things. You could take me to a space rocket. I couldn't just jump in it and figure out how to fly it into space, even though we can't go. But you give me a few hours on, I bet I could get it cranked up.
Mm-hmm. Yeah, but the problem, though, like this concept is not complex, not complicated.
It is complicated, because you wouldn't
Sorry, guys, before you get into that wrangle dangle, I do just want to welcome P Mars and Captain Bullshit. So if I can just say a quick hello to those guys, that'd be really.
I'm gonna let these guys talk for a minute, Nathan. I'm gonna kick out. I'm gonna just mute myself for a little bit. I've talked a lot here, so I'm.
No, I'm not asking you to stop. I'm sorry for the interjection. I just want to say hello to them. That's all. Hi P. Hi Captain Bullshit.
Somebody want to jump in? I'm sorry here. I didn't mean to be hard in the argument here.
Total silence from both of them.
No, it's all right. Well, I was just trying to tab back and forth. I'm just here to ask questions for the chat because people are always like, ask this, ask that, and nobody ever does. Nobody ever asks for the chat. So I'll do
Nathan,
that.
what do you think about my arguments?
Like on a trampoline, right?
Hear half of them, I don't think, because he went offline, so he just barely got back.
Okay, go ahead. I'm sorry. I didn't mean to interrupt you. I'm sorry. I apologize.
Well, I'll have to. No, that's fine. Let me go back to the chat then. Now that we're back, I'll ask people to start their questions with "Ask Neg," so I can search that term.
How about ask me a question? I'll take a question.
I can ask questions for either or. If
anybody, that'd be good.
Yeah.
Sure. Well, let's see. Why does the moon stay the same size all night long?
I don't know. When I went to that Houston mixer down there, it was pretty strange. Right after I got out of there, the thing wasn't out until about midnight, and I drove from Houston to Dallas, right? So it's 250 miles, and that moon stayed and passed me on the way up. The thing will get moving pretty quick, especially it depends on what angle it's going at. I just think there's a lot of questions out there that hadn't been answered that need to be answered.
Well, there are, but I mean, it generally would probably take a longer, kind of more in-depth conversation than the one we've had. Where we
you had never even met me, and it's good to meet you. And I just I get wound out. You know how it is. I've had a long day. I've been out trucking, but I like listening to Flat Earth, and there's a lot of cool people on this deal. But at the same time, it's just time to get to sit down and get a group of guys. I mean, I don't even see, or ladies too. I mean, there's quite a few ladies in this deal, and try to figure out what it would take for the argument to be ended. That's the whole thing that I don't think anybody gets. There has to be an end point to this argument, and it has to be done on the ground. It can't be done in the sky. It can't be done with photos. It can't be done with any of these things. And I don't think anybody stands up and explains it the way that it needs to be explained, to what this whole argument's about and what has to happen for it. These people that think they live on a ball, think that they're living on a ball going 1,000 miles an hour. Okay, folks, faster than the speed of sound. All right. And yeah, I understand you laugh about that, but this is the whole point here. So I want you to, there needs to be 100 points. If there was 100 points that you could prove it other than with pictures, right? This is
other than pictures. Well, so what can I prove it with? What do I do with the
That's what I'm trying to tell you. There ought to be a way on the ground.
There is. Go buy a dumpy level.
It's got, you can't, then why is it be flat? Okay, you can't tell me that thing shows a curve in a straight line. Okay, you're telling me in a straight line through that is photographed. Show me on a stick where the curve is.
Just go buy one. Look,
you can't see far enough with that thing, man.
You can't. Why can't? Why not?
You can't see far enough with it. You can't, because the horizon. The horizon, you can't. There's the horizon. You yourself say you can't. You yourself just a minute ago said you can't see over 3 miles if you're standing 5 foot off the ground.
I said the horizon is 3 miles away.
Okay, so that you can only see to the horizon, correct?
No, it doesn't.
How far can it see?
You can see as long as your eyes can resolve it, and there's light, and there's nothing in the air.
So you laugh about it, but that thing, just like a ship going over the horizon, you can only see it for so far.
Well, look, so at 3 miles is where the horizon starts.
That's as far as that thing can go.
No, it's not as far. If something is 6 miles away, but it's 10 feet tall, that means a portion of that 10-foot object is going to be obstructed from the bottom up.
Let me ask you a question. Let's go back to my deal with the mirrors and the laser. Okay.
Tell me about
if you took a laser and you put it 2 foot off the ground, right? And you're telling me that if I could make that laser go 100, see, the problem with lasers, they can only go so far and they start dissipating, right?
Just like they also expand. They spread out like a cone.
Right, they spread out. So the only way to prove this thing that there's a curve is how many miles would it take for you as a baller for me to go? Just we'll do an imaginary fishing line, right? Well, we got an imaginary fishing line, and this fishing line will go 150 miles, right? Okay, right. And I get it, and I put it, one fishing line's at 1 foot off the ground, right? And I go 150 miles down the beach, and I set another stake a foot off the ground, and in every mile for 150 miles, there's a stake a foot off the ground, and that thing's level for 150 miles, would you still think you live on a ball?
But look, level.
I'm asking you,
Okay,
answer
so
the question.
The surface
Answer
of
the question.
The surface of a
Okay, so we're
sphere
supposed to believe in pictures. Here we
is
go
level.
back to it. That's what I'm trying to tell you, folks. This
I
will
don't even
never.
know what
These
you
guys
just
will
said.
never admit that there's nothing that can prove them one way or the other.
I just showed you.
No, you didn't show me
with the
anything. You
theodolite.
I just asked you a question. You couldn't answer it yes or no.
Okay? So being level isn't the same as being flat. I hope you know that. Right?
Level is
does not
flat,
mean
man.
flat.
Level
No, it
is
doesn't.
flat. Yes,
No,
it
it
is.
doesn't.
That's what the argument is here.
No,
Level is flat. That's why they call it flat Earth, because it's flat and level.
Yeah, but that's why you're wrong, because that's not what the definition of level
So
says.
what?
Level
What
says,
is the what? Go ahead.
All right, so level is where all points on a given plane are the same distance from a stated base, right? So if all points on the surface
level,
of
right?
a table are 5 foot from the ground, that makes the table level, right? If one of those points is 5 foot and an inch, that means that table's cocked up, right? That means it's not level. So the same way, so if you've got a pool ball, right, a spherical pool ball, and if all points on the surface of that pool ball are the same distance to the center, that means the surface is level.
So what would it take to prove you live on level Earth?
Be used to describe the side of a skyscraper, right, left to right. It's not literally, it doesn't have to describe objects that are perpendicular to down.
See, you go when you change the story. You don't ever want to talk. You don't ever want to discuss.
What do you want to discuss?
Where is the curvature? It's like the guy said, that the wiki guy. Remember that? Where is the curvature when he was looking over to Chicago?
Yeah.
Okay, where is the curvature at? Where does it start at? If you're on a ball, there is curvature somewhere. Is that what? Can you tell me there's no curvature because you're standing in one spot? So it doesn't matter how far you go. There's no curvature because you're in a simulation. The next thing you're going to tell me is I'm in a level simulation. That'll be the next thing.
Do you remember the photo with the lighthouse? Where the lighthouse was you could only see the top of it.
Right? How many miles is that? How many miles is it? How many miles is it?
It was 21.
I want to see it. I want to see it with a fishing line a foot off the ground.
A fishing line. A fishing line can be pulled taut enough to get a straight line.
That's why I tried to talk to you about the laser a while ago, where you take the laser with the mirrors.
Right. So that lighthouse, the bottom of it was obstructed by something, by the curve of the Earth. There it is. That's all there is to it.
We have been joined by Sorry to interrupt. We've been joined by Self-Taught. Good to have you here.
Hi, Self.
Hi. How you guys doing? Hey, can you guys hear me?
Can you say a few more words? That'd be great.
Yes. Okay. Yeah, I mean, I just wanted to, jump in and say, I think it's really interesting that David keeps, he brings up that there's doubt. There's doubt to this question. And Negator is like, oh, well, there's no doubt. There's no doubt. But, enough about that. All I really want to say is, David, it'd be great if you could just slow down a little. And maybe let him answer a little more. And Negator, if you would please stop laughing, because a lot of people take this really seriously, and you claim to have answers, and that's fine. I'm here to listen. I'm here to learn. But if you please stop laughing, because it makes me feel like you're not taking it as seriously as you could. Or I know I know he's going off and he's got a lot of questions. He's really firing them at you. But anyway, that's all I really wanted to say at this point.
Okay. Well, I thought I was taking about as seriously as he was. It's obvious he wasn't here for a confrontation or a fight.
They had a pretty good conversation while we were offline for a while there. But I do have a question for you, Nix. Asked in chat, what does the sky prove about the shape of the Earth?
What's the sky? Well, I don't know if I can word this. What does the sky prove? So, I'm sorry, can you all hear my dog in the background?
Yeah, it's fine though. Don't worry.
Yeah, it's distant though. It's not taking over or anything.
Well, it's producing angles, and those angles tell you what angle your local level is, right? Like if you took 2 points on the floor of a room and you both looked at a single point on the sky, or I'm sorry, on the ceiling, you could then generate two angles, right? The angle from level that point 1 is looking at the ceiling, and the angle from level to point 2 is looking at the ceiling, and then the distance between those 2 points, and that gives you, 2 angles and 1 length of a side of a triangle, which then lets you determine the third angle and the other two distances. So you can determine distance to something in the sky. And that distance to something then lets you figure out where it should be once you move around on the surface, if the surface you're on remains flat, right? So if I'm on a flat surface and I look straight up, that object is at 90 degrees. If I'm on a surface that it's at 1 degree gradient, then I have to look 89 degrees straight up to see something directly above me. And I should really whip out a graphic or something, but that leads you to being able to figure out things like, well, Polaris, if I go 70 miles on the surface of the Earth and Polaris moves 1 single degree in the sky, then I'm brain farting here. Then you can keep mapping that out. And on a flat Earth, Polaris would be in a very particular spot. It wouldn't change 1 degree per 70 miles. It would change exponentially. So 70 miles would get you a degree, and then 80 miles would get you a degree, and then 90 miles, and then 100. Not exactly like that, but that's
right,
that's really
incrementally,
crappy
like very small over a great distance, basically.
Yeah, I'd need to put a picture up. I'm sorry, that was a really.
You are a pro at Microsoft Paint, and I really miss your presentation. So feel free to pull it up.
Yeah, let's see. I don't know if I have anything on this computer.
I'll just chime in real quick here. I just
Sure.
want to say, you know, I'm not really, I can't say I'm one way or the other. You know, I'm a fan of the flat earthers. I'll admit that. And I really appreciate some of what they're doing. And it's just, what I really like about this debate is that it requires people to draw just about every form, you know, every single topic you can possibly name, people bring up in this debate. And I can't think of another debate that I've ever really heard of and listened to and delved into that really made me feel passionate about learning as much as I can about the stars and light and, you know, photography and the way the oceans and just about every single topic comes up in this. And that's what I really appreciate. And I'll be honest, you know, I'm only hooked because some of what the flat earthers have been saying is so compelling that it's made me, I can't drop it. Okay, I just can't drop it.
Well,
and believe me, I'm dying to hear something that's really compelling from the other side. And maybe I'm biased. I mean, we're all biased, but I just want to say I really appreciate everybody in this whole debate. And I can't say I really know one way or the other. And that comes back to the doubt. You know, the ballers are always saying there's no doubt. We've settled this. This is settled. We don't even need to be discussing this. And that's fine. But, you know, I just wish that you know, I'm coming around the curve here, no pun intended. Then I almost want to come back where it's just like, okay, I can really jump into the ball pool again. But it's hard because, you know, I'm really stuck in the middle, and I haven't done. I'll admit it, man. I listen all day. You know, I listen, but it's like people's like, oh, you got to go prove, you got to do it yourself. It's like we all listen. We've been listening our entire lives from everything. And so, you know, at some point to me, it almost becomes a point of philosophy. Well, you know, like, are we arguing philosophy here? So anyway, that's all I wanted to say. Thank you.
Okay. Well, the part of the problem with that is, you know, we've been listening all our lives. Is that a lot of all of your folks that I speak to say, well, I got taught the same things. We all learned the same thing in high school. Well, the problem, though, is you didn't learn the specific things you would know to answer this question, because it's not a big part of our lives. It's not something that you need to carry out a successful existence. Right? Like, you don't need to know how internal combustion engines work. All you need to know is, you know, when it gives you problems, you take it to the mechanic and you put gas in it and you air up the tires. And
that's the military talk.
Combustion engines are simple, though.
Yeah.
Sorry,
No.
sorry.
And
combustion engines. Those are so simple. Anyway, go ahead.
Yeah. So when you say you hear lots of compelling things, let's start with that. What's one of the things that you think is really compelling and makes you think?
Before you answer that, can I just say a quick hello to Curved Water? Thank you for being here.
Hey, thanks. I'm not actually here to talk at the moment. I just wanted to see if that would be helpful, and I'm going to mute now. Thanks.
Kirby.
Hey.
Well, on the compelling points, I don't want to bring it up because it's something that no one wants to touch anymore. But I wouldn't be here. I wouldn't be into this at all if it wasn't for the NASA thing. The NASA thing, I don't want to bring it up too much, but to me that's compelling. And then we can get into other more observable things rather than things they're feeding us. That to me seems like, it does seem like bullshit. Oh, sorry, Nathan. Anyway, so I don't know, compelling. I'd have to really, I don't want to get too deep into this. I wanted to kind of stay in the middle because, I don't know, but I don't know.
Mm-hmm. Well, I mean, that would really, that helped me give a start point for this. Your buddies really disarmed me as far as I normally am. I'm ready to go with these things.
Laughter is the best medicine, but not to necessarily derail anybody.
Yeah.
But, well, I have another question from the audience. Flamingo Boot wants to know, what is the most compelling evidence for Earth, either flat or ball? Earth?
Yeah, I mean, I think for it being round, it's that the northern sky spins around Polaris and the southern sky spins around southern celestial pole. And I'm curious why more flat earthers don't have a problem with that.
I did, and I do. Yeah, it makes sense. It doesn't make sense any other way.
So when does it flip?
Well, hang on. How do you feel
So
about
when does
that?
it flip? When you're driving from Chicago to Chile, when does it flip? When do you start seeing? If I'm looking in my rearview mirror and I'm going southbound.
Uh-huh.
Well, there are pictures of star trails, time-lapse photography at the equator, and you can see that the stars are curving away from each other, which shows that they're doing
like the moon does. The moon does that too. They know why would we not think that they do different patterns just like the moon does? I mean,
well, because there's only one moon, but the stars are static,
right,
and so we're moving, and so that's why we can see the star trails.
But that's the problem with this argument is that once we start going to I want to just say that once you start going to outer space to prove this thing, that's what people.
That wasn't in outer space. That's from.
No. I'm just saying that argument of the stars and stuff, and it was like him talking about. That's one of the proofs that helps him. To me, the stars and all that stuff, it has to be done on the ground, and that's what, like I was asking him a minute ago, what does it take to on the ground to find curvature? Nobody will answer.
I showed it to you, and you denied
it.
Do
you want to answer the question first? Do you want to answer the question for your side? What's your most compelling evidence for a flat Earth? Since
water's always level. Okay. That's the number one argument, but no ballers want to argue with that. That's the problem, because water is always level, and they'll just call you dogmatic or whatever, and that's the whole point. It's just like Dale from Beyond the Imaginary Curve. That's his whole argument, but you don't ever see anybody debunk that fact that water is always level. This guy can say that this spirit level device that he has can spot curvature. How far is it? I want to see it on the ground with a measuring stick. That's what everybody wants to see, is a measuring stick on the ground, and you show me the curve. How far do we have to go before we start going downhill on the bottom side of a ball?
How much curve?
Where's the curve? Where is the curve?
How much curve do you want to see?
I don't care. How much curve would it? How about 10 foot? That's all. 10 foot. How far do you got to go to get 10 foot of a curvature? 10 foot will make all the flat earthers quit. I promise you. Just show me 10 foot of curvature, and I'll tell you that it's a ball from now on. I'll get on your side. But you're not going to do it because they're going to argue. It's like this guy. He works for the military. He just told you that it's on a needs and no basis. That's the way he lives his life.
Excuse me, David. Are you ex-Navy? Were you in the Navy?
I'm ex-Navy.
Okay.
I'm ex-Navy.
Stop it with that.
But this is a long time. This is a long time ago. It was a long time ago. See, the reason the military's fine, and I have no problem with the military. They're there to serve a purpose. And I respect everything that they do.
Then shut up about it.
I have no problem with it. The only problem I got with it is that they do, instead of on your I won't even get into that because it's an argument. But I was in the military. I have no problem with it. The problem is that we're trying to make a point here of how to prove this thing to all these people that get on here every day. You got to remember, folks, there are 50-year-old men that don't go to work. They sit on the internet, and people that come on the internet and hear this garbage are automatically turned off and go back out the door. Okay. We have to set up a situation where this thing is proven one way or the other. And they're not going to, until somebody, we get like this guy, if there's nothing that'll ever convince him, he's out of the picture. Then you get to the next baller and you say, what is it going to take? And then we take the top 100 people and we'll flip this thing one way or the other. That's what I don't understand here is what test is it going to take for ballers to believe that it's flat?
Okay, we've been joined by Free-Minded and James Spencer. Just want to get a hello from each of them, if I may. I get a hello from you guys.
Hello. Can you hear me?
Can you hear me?
I can hear you. Perfect.
Okay. This is my first time coming on, but I just had a quick question. Kind of new to it, but one thing that kind of makes me believe. Can you guys hear me?
Yeah, we can hear you fine. It's all good.
Okay, good.
I don't know if James is trying to say hello as well. Is it James
Yeah. Basically, what the question that I have is, how come we don't have like a video from all the satellites that are out there, like basically like a video on the asteroid belt? Because it isn't like a smart place to go to experience gravity and collisions and so on and so forth. The sun is going to shine bright on it because they're huge, right? Some of those rocks are huge. So the sun would shine on the rock like crazy. Some of them are like the size of Texas. So like, why don't they have video of that stuff? It's close. You don't need to wait for a time. It surrounds everything. So why aren't they there watching that for kids in college to teach them about gravity and impacts? We don't have any real video of that. But there's like 40,000 satellites out there.
We've also been joined by Gem Panda 2012, I think it is. And I don't know, before you do, I just want to hear something from Free-Minded just to check. I've popped you on mute just because we could hear your radio or whatever it was in the background. If you can just say a hello, just so I can check. Hello. I know you're good, Jeremy. Thanks for being here. Can you say a hello, Free-Minded? I've popped you on mute, so if you're on a mobile, just tap your screen and then press mute. If you're on a Mac or PC, just move your mouse over the Hangout page and click mute. There we go. Yep, you're back on mute now. Just once more.
Can you hear me?
Yep, there we go. Perfect.
All right, I got it together. What's up?
Good to have you here. Thanks for being here.
Yeah, I got a question for the Globers, because this seems to get ignored a lot. You know, how can we see? It's a lot of photos and so a gang of pictures that show us seeing objects that we're not supposed to be able to see. So how do you explain that on around Earth? All these pictures, we're seeing hundreds of miles, 200 miles, and when you look at the chart, you're not supposed to be able to see it.
They're doing.
Well, how do you get around with that? How do you get around that?
They're not entering the observer height when they're doing the math.
They are. I mean, it's a whole bunch of them, man. You can search the web. It's all kind of pictures. I've seen stuff I'm not supposed to be able to see.
They're fucking up the observer height. Oh, excuse my French. Yeah, they're messing up they're not accounting for the observer height in their equations. That's why they get like. There's nothing they've shown that they shouldn't see, and in fact, a lot of those things prove that like we live on a ball because they show obstruction of the horizon.
Sorry, guys, I had to drop unexpectedly.
It's been a pleasure.
Well, I'm good now.
Oh, right, I see. You're back. Thank you for coming back. Good to see you again.
But
in order to really
no one's
talk
going
about
to
that,
answer why we don't have the.
I mean, so the answer is you just don't think they did the experiment right. I mean, it's a couple of really good ones where they show.
Yeah.
I forgot the girl's name. I think it was the CNN tower, some tower in Canada.
Yeah, Jenna Fredo shows curvature.
Yeah.
Why don't you link your specific example? Yeah, we can go over that. Link your specific example so that we can get the details of
you can go on my page.
Hey, referring
you can go on my page and see it.
I'm not going anywhere.
How does that show? You're not even supposed to see that. You ain't even supposed to see the building, but you can see all of it.
Hey, why are they angled?
She shows you where she's at. She points the camera to her feet.
Let's get the right facts
see the water.
Get the right facts.
Let's get it. Let's get it.
It's a circular argument. They'll never admit to anything. That's why I keep trying to get them. Tell them what experiment would it take for them to prove it to them.
I'll admit to the fact that you're doing the math wrong and making false claims.
How far do you have to go on the ground at 12 inches off the ground? How many miles do you have to go before you see the curvature? How many miles, 12 inches off the ground, on the beach, on the water, at a level water? How far do you have to go? How many miles do you have to go to prove that there's curvature? How far?
David, I showed you a picture of curvature.
I don't care about these pictures. That's what you always do. These arguments always go back to somebody else's experiment, other deal.
What picture? I didn't see the picture of curvature. I want to see that. I've been looking for like 3 years. I ain't never seen it.
What does it matter who owns it? It doesn't matter who owns it. You've been looking for 3 years, really? Here,
I want to see the picture.
Everyone can only present somebody else's experiment, can't they?
I want to see the picture.
Even if you present your own experiment, to us, it's somebody else's experiment. So that's all anyone can present.
Yeah, just like the picture of Earth from space. That was
here,
another
here
picture.
You go. I'm presenting right now. Do you see me free?
Yeah, hold on. You just clicked. Okay.
There you go.
Yeah.
So do you know what I'm looking at here?
Yeah, I see what you're looking. What is that building in the background?
So that is a lighthouse.
Okay.
And here's the problem. There's a couple problems in this picture. The one is that green line represents horizontal. That lighthouse is below the observer's horizontal, right? On a flat Earth, that would be impossible. Number two is the bottom of that lighthouse that connects to the land is entirely obstructed.
That's because the water is in your way.
Of course, the water is
in my
way.
If you understand, first of all, you got to understand perspective.
Perspective doesn't move
your
objects.
Eyes work.
No, your eyes don't move objects either. All right. Perspective does not cover things up. It makes things smaller and larger uniformly. Okay?
No, it does cover things up. You need to. You might want to Google that, or I don't know how.
Well, okay, if you can Google that for me so I can read it, please show me.
Yeah, I mean, I got a video. Hey, go on my page.
And what's on your?
I got about 15. I think I got about 10, 15 videos, and it will show you. I got a long video on perspective. It's not mine.
Well, I don't know. I don't want to.
It explains it.
No, I don't want to hear you saying the same thing over and over again. Right. I want
you to you're not listening. It's like you're not being intellectually honest.
They're not ever going to listen.
That's what it seemed like.
No. Intellectual honesty is not saying things like perspective covers things up. You tell me, how do the light rays bend so that I can see an object up close, but I can't see it far away, only half of it? How does that work? How does the water get up higher?
Because it's closer to you.
So when things get closer,
that water
they
right
literally
there is
raise
closer to you than that tower in the back.
So that water is raised.
That line right there from where whoever took that is at. That is their false horizon right there. That water line.
I'm sorry, one moment.
I mean, how does you can go on a football field, lay down, and you will see something like this. You won't see the bottom of people's feet on the other side of the field. It's the same thing, but the field is not round. The field is not a globe.
So you're saying that when
it's the same kind of perspective. It's the same.
You're saying when you look at the other end of a football field, you can't see the player's feet.
Now I'm gonna go to one of the end zones, lay on the ground, and see if you can see the goal post at the other end.
It's true because football fields aren't flat.
Yes, they are, man.
No, they're not.
Long ways they are.
They have higher elevation
for drainage.
So if you are a recent joiner to this Part B live stream, welcome to Flat Earth Debate, and if you are new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live, and if you would like to join the debate, there is a link in the info box below this video. With your watch page muted, simply click on that link to join the debate live. There are only a couple of rules in the Hangout. Please do not swear, and please do not try to rejoin the show if you are ejected. Please share the show on Skype, Facebook, Twitter, and any other social media platform that is available to you. I will pass you back over to the action.
60-degree camera, and at sea level, you can see the curve.
All right, you asked me.
No, you can't.
You asked
Yes,
me
you
a
can.
question.
I've seen it mathematically modeled. Yes, you can. You're incorrect. I've seen it mathematically mapped out by someone who has a 360 camera.
I did 4
Look,
years.
you just haven't done the research I have.
I've been out to sea plenty of times. You just can't do that.
I've seen someone with a 360, a Russian guy, a scientist, like mathematical guy. He mapped out his 360-degree camera, and the horizon is not horizontal. So I'm just sorry, it's not. You just need a tool to measure it. If you eyeball it, yeah, it looks horizontal, but like, you know, you could eyeball someone and guess how tall they are, but you're not going to know until you actually take a ruler out and check. So I mean, that's the same thing, but you guys aren't willing to do that for some reason.
That's why I showed you that photo.
Sorry, go ahead, Nick.
No, I was saying that's why I showed you that photo of the lighthouse below your horizontal. That's simply impossible. Perspective does not move objects below your horizontal when they're at the same elevation. Right?
Yes, it does. I mean,
if you're looking down the length of a table, right,
yeah,
place an object at the end of that table, it's still at the same level as your eyes.
But
right?
you won't be able to see, depending on how long the table is, you won't be able to see the bottom of that object.
That's nonsense.
Now the table is flat. I mean, you can do that right now. I'm pretty sure you got a table.
It's all got to do with how far you can see.
Put you a ketchup bottle on it, and your table is flat. You know that, and go to the edge of it, and just the bottom of it will be missing, man.
No, that's entirely nonsense. It's made up nonsense. Let me show you this photo. Do you see this photo here that I'm screen sharing?
Yeah.
So this photo was taken. This hallway is 300 feet long, and when you zoom in on this photo, right, you can even see the shadow cast on the ground by this vending machine here on the right. Okay.
Yeah, that looks like a lot of flat Earth footage when we can see stuff further and see the whole thing.
No, you were telling me a second ago that flat surfaces jump up to obstruct things. I'm showing you a picture.
Well, it depends on how high off the ground you are and how far.
Well, the camera sensor in my phone was about 1 inch off the ground here.
Okay.
Okay. So 300 feet, 1 inch off the ground, I can see the shadow on the ground being cast by that vending machine in front of me.
What does that? So what does that prove?
It proves that I see the entirety of the object in the distance. There's no point at which a flat surface will jump up to obstruct something. This is a lie that's been repeated by flat earthers utilizing.
I mean, if you're gonna have evidence like this, can you prove all of what you just said? You're 1 inch off the ground, just like you said with the Jenna Frater footage or whatever. It doesn't really show how far you're off. So I gotta take your word for it.
You're shifting the goalpost again. Yeah, you got to.
I'm not shifting it, man. I'm going by your rules.
Yeah. So how would I take your word? Would I get a second camera? Would I get a second camera and take a picture of my first camera? But then how would I corroborate that?
Look, can you show me that? Can you show me the mathematics on how you wouldn't be able to see that or not? You know, the distance and all that.
Mathematics, because flat surfaces are flat. That's the end of story.
But if you backed up, if you kept backing up, would it stay like that?
If that surface was literally
if you backed up another 300 feet, do that and let me see it.
You're shifting the goalpost. So let me ask you this. If I showed you a minute ago, you said the table, right? If I backed up, that table would obstruct. The table's only 6 feet long. I show you 300 feet and you want me to back up further. But the table a minute ago was good enough for you. Now, if I started with a photo at 10 feet, you would have said, well, back up to 20. Then I could have backed up to 20, but then 100. Well, now you want me to go 600, right? Nothing's good enough.
Why not?
Right? What do you mean, why not? Because the building has walls.
That's not good enough for me. That's not good enough for me.
So it disproves everything you said about perspective, but you don't like it.
No, I don't. Right? Back up further, and if it's the same, then you're right.
So the difference from 300 to 600 feet is the magic distance for you.
But you know, you got, I mean, in an experiment, you got to control, and then you got to, you know, you can't just take one picture.
So you tell me how a 600-foot distance automatically applies to control, but 300 feet, there's no control.
I've got a question.
Okay, you got your 300 feet. Now compare it to a 600 foot. You see what I'm saying?
So why does that 300 feet make the difference for you? Why couldn't we go from 100 to 300 feet?
Well, let's do it. We can do it all, but an experiment is not just taking one picture. You know.
So you're
actually
just
a video,
the photo. So
video would be even better if you just backing up slowly and seeing if you can.
Would you like me to do that? Because I work there. I can do that tomorrow.
Right? Okay.
I can only go from 300 feet down to 0 because that's the length of the building. The building's like 330 feet long. Right.
I would like to see it.
And what do you think is going to be different about that video than this photograph? Because that photo was taken at max.
I think you're not going to be able to see the shadows and stuff at the bottom as clear as you would if you was closer.
But
you know what I'm saying? I can't tell you exactly what you're going to see, but it's going to be different. It's going to be a different picture than what you just showed me.
So
you're going to be able to see less. No, I said further. If you got further.
Okay.
That's perspective. Of course, you're gonna see less.
That's not perspective. Like you just made that up. Flat earthers have made up this idea that perspective hides things.
It does.
You show me that happening. Is this this where you show me the guy walking away from you on a football field?
Yeah, you've seen that video too, huh?
Yeah. So do you know what a crown is?
No, explain that to me.
You don't. Football fields are made with a hump to drain water away from it. Number one. Number two, there's nothing in this video.
How much is it tilted?
The football field to actually be literally flat, right? There's nothing in there. All right. Are you going to show me the one?
How much does the crown tilt?
Oh, I don't know. I didn't mention this particular field, but I know they have crowns.
So how do you know it has a crown if you can't tell me the specs on the crown?
So wait a minute. You're telling me that I need to know the specs for it to be real? What are the specs of a 97 Camaro?
So I can just say some shit and not prove it?
No. You're asking.
Well, that's what you're doing, aren't you?
Yeah, that is what you're doing.
There is no crown.
Hey, man,
I didn't say there was no crown. I just want to see proof of it. I didn't say there was no crown.
They can't answer.
Why don't you do the thing and you can Google football field crown? Right, that's what I did.
You have to ask them questions that they can't answer. Okay, how about like this? Okay, you say that the flat Earth is.
I want to see proof. I want to see perspective cutting things off.
No, let me say something.
Now you talked a lot, Dave, and that was real nice.
I know. I just want to say one thing here, and then I'll shut up. Okay, the flat Earth is a table, right? You said a flat table. That's what flat earthers say, that we live on a flat table. Okay,
sure.
And you say we live on a round ball. On my flat table, how far do we have to go on your round ball if you're on my flat table to prove that there's curvature? How far? You see what I'm getting at?
Well, David,
you're not going to answer the question. You see, guys, everybody that's listening to this, they never answer the questions. All they do is they go back and they circle back around.
I'm still trying to understand the question. If you're traveling around the ball, what is it you're expecting to see?
How far on the land do you have to go to get curvature? On a flat plane,
get curvature. What does that mean? What would get curvature feel like?
From the top of the ball is 25 to the bottom of the ball is 12,500 miles, right?
Right.
Okay. So for every mile that you start at the top, you're going downhill. If the North Pole was straight up and down, and you'd be going downhill to go to the bottom, right?
You don't go down
north and south. We'll just call it north and south, okay? However you want to do it on the ball.
No, you're always going downhill on a ball.
No, you're
not.
No, you're not. That's stupid. That is stupid.
Downhill.
So you're going flat on the ball, then?
Downhill is a change in elevation.
Or downhill? Which one is it?
Elevation free. Elevation.
How far on the flat table do you got to go before you see curvature?
How far on the flat table do you have to go before you see curvature? I want
where's your curvature at? Where's
the curvature on a flat table? Why are you asking this question?
Because he's telling me that I live on a round ball, and there's no proof that I live on a round ball. The water's always level.
Why do you think that by traveling the curvature will reveal itself? I still don't get this. What is it that you're expecting to see as you travel?
Okay, every mile that you travel north and south, right?
Right.
There is an up and a down. If north is up, and because when north is up and south is down, right?
Okay.
How far do you, if you start at the north and you go down 12,500 miles, when you start at the top, you're at the top of the ball. When you get to the world you live in, the big spinning ball, okay? If you travel from the top of the ball to the bottom of the ball and you're riding upside down, when you get there, there's curvature somewhere when you get there, correct? How many miles is it that you have to go before you detect a curvature? If I took a fishing string.
Stop. When you say detect, what do you mean by detect?
This guy keeps saying that we can detect the curve by these buildings.
No,
how do you detect
what specifically do you mean by detect? How would we go about detecting it?
You would go about it by detecting the curvature of the Earth by the number of miles. Is exactly how you calculate the curvature.
Does anybody else know what he means?
No, you don't know what I mean because you're not going to answer the question.
I can't understand what it is.
We just want proof of curvature, pretty much, man.
I have his answer. I was trying to tell it to him earlier, but
oh, sorry, Kev. Go ahead,
David.
Yeah, here we go.
You asked how many miles for 10 foot of curve. Now, in 4 miles, the math calculates that would be 10 foot, 8 inches of curve, which is specifically the drop from horizontal at that distance.
Oh, that's drop from horizontal, right?
That's, yeah, drop.
Yeah. Okay.
That is drop from horizontal, like you have a dumpy level. You're shooting your horizontal line there.
So it only take 8 miles if I took a fishing string out. If I took a fishing string out and I took it a foot off the ground and I had that fishing string go 8 miles and it didn't curve, you guys would become flat earthers. Is that what you're telling me?
You can't stretch a fishing line that far.
This is an imaginary. This is an imaginary fishing line now, just like you got the imaginary curve. Right. Okay.
Well, then, are we going to imagine that we did the test?
No, we're not going to imagine that we did the test. That's what we're here to talk about, is how to prove this thing one way or the other. That's where you guys never want to talk about.
do the test if you have to imagine that the fishing line will stay.
Because you're going to have to figure out a way to do it that's as accurate.
Yeah, how are you going to prove curvature? How can you prove curvature? I haven't. Where's the proof of the curvature?
Because if you take a fishing line and you just take this imaginary fishing line out and you stretch it 150 miles, it shouldn't be 12 inches off the ground at mile 1 and mile 150. Is that right?
Yeah, that's the. So are you asserting that the imaginary fishing line is straight, like literally straight?
Level. We're going to use a spirit level at every mile.
Level to the ground will always have it the same distance.
Exactly. So you're telling me there's no curvature?
No, that's not what that means.
It's always level. Question. You're not going to answer the question.
You're not going to do. Because David, look, the bottom line. I've been trying to be really nice, but it's a dumb question. Okay.
Yeah, sure it is.
The nonsensical question using a situation that is equally not
pointed at a whole nother direction. 6 months later. Do you agree with that? You're on the other side of the sun, right? You're on the other side of the sun, looking away from the sun, right?
Right, and what you're
suggesting. How can I see something behind me? And it's supposed to be in front of me.
Let me make sure I understand. You're suggesting that 6 months later, when it's the middle of the night, and you live on the opposite side of the globe as the Earth, or the sun rather, that you're looking directly away from the sun, and you're telling me that you see, and that's that point in the sky, the same constellation. Is that what you're telling me?
Yes.
So which constellation is that?
I mean, you could. What use Polaris?
Are you serious? Like, are you serious right now? I don't even know what to do with this.
What you mean?
First of all, Polaris is not a constellation. Second of all,
I'm not saying it's a constellation. That doesn't matter. All right, the Big Dipper.
Oh my goodness.
How come I can always see the Big Dipper, man? It's a different place.
The Big Dipper is not on the opposite side of the Earth as the sun.
It's not. Yeah, so how? Again. Look, man. Look, you got to visualize this. There's a sun. We're going around it, right? No. When you're looking out, when you're looking up, you're looking out away from the sun, right? You're looking out.
Now
but 6 months later, you're looking a totally different direction. How can that happen? How can you see the same stars, bro?
Hang on. You're telling me that you see the same stars, but you have no idea which stars those are. That tells me that you
said the Big Dipper. The Big Dipper, bro. The Big Dipper. Right?
The Big Dipper.
The Big Dipper.
That's a good point. I wanted to bring this up.
How do you do that?
He brought it up.
I like
his point here because he brought up a good point. And I want to try to I wanted to bring this up, and this is something.
It's a very good point. You can't answer
it because he doesn't understand the stars.
Let me finish.
Sure,
that's fine. You can say that. I just want to say two things. It was about the compelling evidence, and this is why I'm here. You know, I don't know, and I appreciate everyone who has questions and everyone who has answers. So anyway, I just wanted to try to rephrase this question because it was the question I wanted to get at. Okay, so we're rotating. Okay, we're rotating, and that's why we see the day and night. Okay, so we see the same stars, okay, every night because during the day the sun goes by, stars, and at night we see the stars again. All right, so let me finish here. So in 6 months we're on the other side, and once again, I saw a video on this. I'm not saying I know. I'm just saying we're back to this compelling point. So just let me finish. I have another question too. So we're on the other side of the sun, out a whole nother side of perspective. You know, every night it's in 6 months when we go around, it's a whole new season. We're on the other side of the sun, rotating, and that's why we see day and night. Why don't the stars change?
The bottom line is
that was one compelling point, and then
first of all, it's not
the other point I thought was compelling, and you guys can address this. I'll get out. I just wanted to bring up the questions. Okay, the second compelling point was for me why I'm here. Okay, the videos we see of balloon footage claiming to be 120,000 feet in the air, and they appear flat. So anyway, those are the two. You come back to the compelling points. Those are it. I'd like to hear answers on.
Okay, so
start with the first one. Start with the
first. Yeah, the stars. The bottom line here is that when you look directly away from the sun at the middle of the night, 6 months apart, you do see different stars, right? You absolutely 100% do. Okay,
they're in different positions. They're not different. I can see the Big Dipper all year round.
There's one
on the so-called northern hemisphere. You can see the Big Dipper all year round, bro.
You're right. Let me break this down for you. Yeah, look, buddy. All right.
Yeah, let him finish.
Let's break this down for you. You're standing in a room, and this room is circular. Okay. Now, on the walls of this room are printed the 13, I think it's 13 ecliptic constellations, right? And you, right, at the center of this room, this represents, our orbit around the sun. So when you look to your 12 o'clock, you see one constellation. And when you turn 180 degrees to your 6 o'clock, you see another constellation, right? Okay.
100. What did you say? Basically, I turned around
180 degrees.
180. Yeah, I'm facing the sun again.
Hang on. I'm talking. Imagine there's a sun in the middle of the room, and you're walking around it, and as you're walking around it, you're facing away from the sun, so that you're facing towards the walls.
Yes. Right. So how can I see the other wall?
Now, the Big Dipper is printed on the ceiling above you.
No, it's not. It's in front of me.
No, it's not.
It's in front of me. When you look up, you're looking out, bro. You're looking out.
My goodness. Do I need to draw pictures?
Yeah, you do.
I think I got to draw some pictures.
From your.
All right, he's breaking up. So I'm gonna try here, right? So here's you got me. Do you see my picture I'm about to draw?
Yeah, I see it. I got you.
So there's my sun in the middle.
No, let him finish.
All right, and here's my let's do my Earth right here, right? And then I'm gonna draw my I'm gonna draw myself an orbit as well around the sun. So the black line represents my orbit.
Right.
Okay. And then my red stuff, let's say we got a constellation here and some stars here, some stars here, stars here, here.
No, but I mean, we can't see those on the right. I mean, we can't. All right, the Earth is the green circle. So
yeah, the Earth is the green circle.
You can only see the stars.
Now, when you're looking,
bring the picture back up.
When you're looking, you got to click on my name. When you're looking directly away from the sun, that represents this line here in the middle of the night.
Exactly.
Right. So this is 90 degrees above you. That point in the sky represents when you look directly up. Now you can still see. Right. You can still see everything to the south side of this red line. Right. You can see the stars over here, and you can see these stars. You can see these. You can see these. But these stars right here, they're directly above you. Okay.
Yeah.
Does that start to make sense? So in 6 months, when the Earth is here, and you look directly away, 90 degrees, you see these stars, this constellation, right? And that's what we see in reality. You look directly away from the sun.
I'm talking about the Big Dipper. You can see the Big Dipper all year round.
Now,
so how can I see what you drew that first line to? How can I see that on the other side?
Consider the perspective where my drawing is drawn from, right? The way we're looking at it right now is top down. We're looking at it as if you are Polaris, right? Now the Big Dipper is near Polaris. It's on the ceiling of our round room.
Yes,
right?
It is. It goes around Polaris. Yeah, like a Nazi sign.
Right.
Yep.
So when you're in that round room I was describing earlier, and you look up, at any given time you can look up and see Polaris, and you can see the stars and constellations that are near to Polaris. Right. So
yeah, that's impossible on a.
How is that
impossible? How can you see? How can I see behind myself?
But you're not seeing behind. The Polaris isn't. Or I'm sorry. I really need a 3D model for this paint. It's just not going to do it.
How can I see something that's behind me?
You need a 3D.
It's not behind.
So the audience knows I'm going to be rounding out this show in about 5 minutes time. So if you did want to join to do any last minute trolling, now is your opportunity. Be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. And if you'd like to support the channel, there is a super chat that runs while this show is live. The rules still apply. Please do not swear. You will be ejected if you swear even in these closing parts of the show. So I'm going to pass back to the action, and then I will thank the audience in a few minutes time for joining us.
The thing is in the whole
that you can see.
Right. The Big Dipper is in that area.
Yeah, the Big Dipper.
So if I'm on the other side, I cannot see anything.
It's the Big Dipper near the horizon when you see it.
The horizon, yeah.
It's low and near the horizon.
But you're not supposed. You can't. How do you see it at all when you're?
Well, are you saying
the sun is supposed to be blocking it?
Are you saying?
You get what I'm saying?
Are you saying it is low and near the horizon when you see it?
It depends on where you're at on Earth.
No, when you see
how far north you are, huh?
When you see it from where you're at, is it near the horizon?
Where I'm at right now, I can't see the Big Dipper right now. I'm in Japan. I haven't looked at it, but when I was in the States, I could see it.
Right. And was it near the horizon?
Let me think. No, I don't think so.
Can I just say this?
I don't think it was near. It wasn't straight above me.
Right. Not straight above you, but
you
not
shouldn't be able to see anything. Like right now, tonight, if I look up at the sky and I see the stars, 6 months later, I should not be able to see any of those stars.
But what about the ones that are above you? The ones that aren't near the horizon?
Just so you guys know, this show is going to be rounded out in about 2 or 3 minutes' time. So if there's any compelling points you need to get across, now's the time to do it.
I did want to say something. So I was reading this book called Darwin and the New World Order by Ian T. Taylor, which is pretty interesting because it's about how the theory of Darwin's theory of evolution isn't really based on facts, but it's based on a popular or political agenda, right? So
no, right.
There's this yeah, no, it's true.
No, yeah,
it's true. You should actually read this book. Right. So on page 36 in this book, he's talking about how to keep a popular theory and going and believable. All they have to do is hire people that'll conform to the theory at university and government research labs. If they don't conform, then they just don't hire them. And in the book, it says, the situation was no different from any university or government research laboratory of today. The candidate for employment first had to show evidence of conforming to the ideas of the establishment. Once accepted, conformity was expected in order to ensure continuation of salary and promotion. The system virtually guarantees maintenance of any theory, regardless of whether the theory is sound or not, held by the man with ultimate authority. Not only that, but in the hierarchical system, promotion from within ensures that the theory is perpetuated generation after generation. So I thought flat earthers might be interested to hear that.
I'm going to say a massive thank you to all of the live audience who have joined us on this epic 2-part debate. Thank you very much indeed for joining us. Make sure to like, comment, share and subscribe. I've been Nathan Oakley, and I will see you all in the next video.